So welcome back to our study group. I can't believe we're actually over halfway done completing the first part of the book. It's actually kind of crazy how quick the weeks have flown by. In case you missed it, last week there were no slides because I was out of electricity for a bit, but we covered data models and query languages in chapter 2, and we had some pretty great discussion on relational document and graph models, a lot of programming language talk, which was interesting and out of my league, but it was fun to learn about, and just choosing data models in general. And you can find a summary document I wrote up pretty late early this week in the data intensive channel. So this week, week 4, we covered storage and retrieval. So I really enjoyed and found the chapter section on data structures that enable database indexing to be pretty enlightening. So database indexes are meant to aid in locating data in your database and speed up read queries. And Kleppmann kind of goes into detail on the various ways on their implementation. And I just found it immensely satisfying. I don't know if I talked about it earlier before I started recording, but just because of the fact that it makes use of quite a lot of what a student would learn in data structures classes, from things like trees, hash tables, and the like. And I also really appreciated how in the chapter Kleppmann actually talks about the consequences of these data structures and what they have, their effect on the underlying hardware. I believe in one section he talks about write amplification, which is kind of the effect of writes to the database that result in multiple writes to the disk over the course of the database's lifetime, and how it can affect things like SSDs over time and how it can degrade them. And the section also talks about the popularity of B trees and the relational model, which was, I think Phil mentioned just a light touch on the relational model that Kleppmann doesn't really expound upon throughout the rest of the chapter. And a lot of interesting information on just the reliability and consistency guarantees that these data structures have, like having a write-ahead log and such for B trees, as well as just having a log in general. So if power goes out or some other catastrophic event happens, all that needs to be done is to follow the log, and um, the index can sort of be rebuilt. That is the keys, I think. Also, I wasn't really aware, or I just forgot that too, about like the history behind the database term transaction, which kind of goes back to the early days of business data processing. And in this section, transaction processing and analytics, we get a glimpse into what is known as OLAP, online analytics processing, or data warehousing, and how it came about. Oh, and in case you haven't read the chapter, the term transaction is just a group of reads or writes that form a logical unit in the database. So with most database operations for applications like e-commerce, gaming, and such, a lot of these operations just look up a small number of records, right, using the index. And these records are updated or inserted based on input, and that's known as OLTP, or online transaction processing. And to summarize things, just because due to increased database usage by business analysts for data analytics, which access large amounts of records that can affect what should be a highly available and low latency transactional system, that kind of led to data warehouses, which are separate read-only databases that analysts can freely use. And often the schema between these two systems, OLAP and OLTP, often differs greatly, and Kleppmann kind of goes into that. And one other thing that I came to realize was just how much Google kind of has had an effect on data storage and the things discussed in this chapter. I believe uh, the previous section, when Kleppmann was talking about SS tables, Google had a separate paper off of which SS tables were developed. And as for data warehousing, Google has some sort of system called Dremel, which I haven't looked much into, but that seems to have had a pretty big effect on the whole development of that particular field. And as for the last part, which I unfortunately did not really get into, it basically deals with column-oriented storage, which I think are optimized for analytics, as the chapter describes early on. And the reader gets to see how these storage engines minimize demands on hardware and on fun things like materialized views and data cubes. And that's the end of my slides. So let's get to discussion.